Now that it's possible to build Shiny apps in Python, you can now tap into the vast ecosystem of packages and integrate them into your Shiny apps. It's always nice to introduce an open source package and stand on top of giants. Shiny Semantic in Shiny for Python is the implementation of the rshiny package, Shiny Semantic in Python. And we have one of the authors of the package to talk more about it. Pavel Demin is a Shiny developer at Epsilon. He's a self-taught developer with background in social science and statistics. Pavel enjoys multilingual environment with various modern technologies, delivering solutions in R, Python, and React. So let's dive into the talk.
Thank you for the introduction, Veda. Hi, my name is Pavel, and today I'll be sharing with you my experience of porting Shiny Semantic from rshiny over to Shiny for Python. This is the agenda for my talk. First, we will cover the necessary glossary. We will cover the results of this experiment, and then I will start talking about the experience of the developer. Finally, we will jump to conclusions, and we will have a discussion section. So before we proceed, I want us to be on the same page, and I want to have this small refresher on key libraries that I mentioned in my presentation. So obviously you all know what Shiny is, but here are some libraries that some of you might not be so familiar with. First and foremost, this is Semantic UI, front-end framework, which is the key thing in this whole process, in particular in Shiny Semantic. So this is basically a library written in HTML, JavaScript, and CSS that creates those components that you see in the browser when you run your Shiny application. Next, Shiny Semantic is the rshiny package that adapts Semantic UI. It brings it into the rshiny world, and it exports R functions so that the user can generate HTML code by writing R functions instead of HTML. And also, it provides us with Shiny bindings. This is what is responsible for the communication between the Shiny server and Shiny client. This is how you can render and update the components in Shiny Semantic. Finally, PyShiny, or Shiny for Python, is a re-implementation of Shiny in Python. And I want to stress the most here that the server part of Shiny has been rewritten in Python. However, the client side remains unchanged. And it means for us that for building Shiny bindings has got to be the same, which means that we probably can reuse those from Shiny Semantic. Now that we're on the same page, let's begin. Although this experiment was mostly about ideas, impressions, and knowledge, it also has some tangible results. So if you're interested, you can check them out. First of all, although the package, the PyShiny Semantic, is in its earliest stage possible, it's already available on PyPI. You can install it with pip and play around. The source code of the package it's hosted on GitHub. And we even created 2 demo applications which were supposed to help us during the development process. You see them on the GIFs on the slide. So one is just a demo of Shiny Semantic components, and another one is a copy of a Shiny app featured on Posit Gallery in PyShiny, which is a t-test simulation. Now, I can sense that there has been too many instances of word semantic, so maybe we can figure it out with this simple graph. So first there was Shiny, and rshiny by default uses Bootstrap 3, and Bootstrap is cool until everybody uses Bootstrap. And what's cooler than Bootstrap is the ability for your application to stand out from the crowd. And this is why Epsilon team has decided to bring Semantic UI into rshiny by building the Shiny Semantic package. Sometime later, Semantic UI was not very well maintained, and the dependency on it was replaced with Semantic UI, which is a community fork of Semantic, which is actively maintained. However, the name of Shiny Semantic has stayed the same for the compatibility reasons and for some other reasons. Fast forward to these days, Shiny for Python is released, and we started experimenting with it almost immediately. And eventually, we had an idea of taking one of Epsilon's open source packages in our Shiny and try to port it into Shiny for Python and see how it goes. We chose Shiny Semantic for various reasons. First of all, it's arguably a signature package of Epsilon. It has most stars on GitHub. It's recognized by the community, and it would spark some interest. Second, and even more important, the Semantic UI as a front-end library is pretty much self-contained. So unlike Fluent UI, which stands behind another Epsilon's package, Shiny Fluent, Fluent UI, although it looks beautiful, it's very nice, it relies on React to work. And for our experiment, it would mean one extra dependency, one extra thing to care about, and we didn't want that. We wanted to isolate the experiment. This is why Shiny Semantic seemed to be a perfect candidate for this task. And so, okay, Shiny Semantic it is. Let's start the development. And as you've noticed on the graph, this PyShiny Semantic, maybe I'll show it one more time, it has 3 incoming arrows from Shiny Semantic, from Semantic UI, and from PyShiny. And I call these arrows sources of inspiration. So what is a source of inspiration? A good way to think about it is in the form of a question. I want my package to make most sense from the perspective of which technology? And this question can be generalized to what target audience do I expect for my package? Namely, what was the entry point of the developer who will be using this package into the Shiny world? Was it an R-Shiny developer who is transitioning to PyShiny? Is it a front-end developer who is familiar with Semantic UI, other front-end libraries, and they want to start doing Shiny? Or is it a Python developer who learned about PyShiny and now wants to build interactive apps using this library? These are all more important questions, and they really affect in how we want to structure the application to build the API itself. And these 3 sources of inspiration ultimately resulted in 3 stages of development, which were not predefined, but rather changed each other one after another. And retrospectively, I named them after the corresponding packages, which acted like sources of inspiration. But this is all good. These are all valid points, but let's get back to earth. When we just started developing the package, we didn't even think about how is it going to go to the open source, to the public, what is the target audience. We didn't know how it would go at all. So instead of overthinking it, we decided to let it flow naturally, and let's just start building and see how it goes. That was the approach. And we first approached the development with this reckless thought. Let's translate existing R code into Python, like a proof of concept. Can we do that? And actually, a great idea. Why not? If it's possible, that's great news, right? It might seem reckless at first sight. However, if you take Shiny apps are built, you will immediately notice a lot of similarities. Look at the screenshots. One is an example in R, a snippet in R. Second is in Python, and they are very similar. And this happens because of the great effort of the developer team behind PyShiny. And as a package developer, I'm especially a huge fan of HTML tools, which has been brought over to Python. What you see is basically HTML tools. This is a package, both in R and Python, which provides you with functions that you write that generate HTML code that I mentioned before. Take this and combine it with the fact that Shiny bindings can be reused. And this thought already doesn't seem insane, right? It makes perfect sense. Moreover, I want to add it here that As an shiny developer who uses Rhino extensively, the transition to Python seemed to be very natural, because in a Rhino application in R, you won't see a calls to a library or source function. Instead, you import each box module explicitly, most often naming each function in the module explicitly that you need. And this way you really granularly can control export and import flows of the code. And because of this, writing Python code, a Python application seemed not intimidating, but familiar and helpful. And this just felt amazing. But now UI code is great, but it's not all right. And well, Python is not R. You have to write functions. You have to define some logic, structure modules. Those functions need to do something. And the more you do that, or you start, well, writing Python code instead of translating R code, you want to use genuine Python features. It starts from small things like list comprehension, which replaces some part of your code. Then you take some other parts and you want to change them. You want to refactor something. Maybe in some places you want to bring part of your own personality to the project instead of copy pasting it. Uh, yeah, and eventually you catch yourself on the thought that you're no longer translating the R code, the R package. Instead, you are re-implementing it in another language. And next logical thought that you have is, why would you want to re-implement a package that implements Semantic UI? Instead, maybe I should just implement Semantic UI directly, but in Python. And this is how this first stage started smoothly transitioning into the second stage. But before we go to the second stage, I want to highlight that each stage has its own unique perks that we had and takeaways. And the crucial takeaway of this first stage of the Shiny semantic stage is Shiny bindings, obviously. Some of them we were able to literally copy paste, while others we had to slightly modify, but it was not substantial. It was a very nice reuse of the existing code base. We also had huge inspiration in general ideas, how things might work, etc. So with these takeaways, we're smoothly going to the next stage, the semantic UI stage. So again, it was not a predefined transition. It was all going organically, sort of naturally. And the reasons for the transition to this sort of stage are not only the ones that I mentioned in the previous slides, but also the fact that as the project grows, well, it's still a small project. It's not like a giant application or something. But anyway, as the project grows, I create more and more files, and eventually I start thinking about how should I structure these files. And here is where, combined with the previous thought that we should implement Semantic UI directly instead of looking too much at Shiny semantic R implementation, combined with this, you take a look at the Semantic UI page, and it seems like it's very nicely structured and very logically. So you have distinct sections, you have elements, collections, views, and modules. And now it's a good time to remember that unlike an R package, which requires a flat structure where you would put all your R scripts into R folder, Python allows for nesting, and we can have those nice submodules, each responsible for a corresponding section in the Semantic UI. And this approach, when we want to mimic the structure and naming conventions of the original underlying library, it has a huge bonus, in my opinion. It's we kind of leverage the original documentation of the library. So when a PyShiny developer is interested in how module.dropdown function works, they immediately understand that they can navigate to the corresponding section on the Semantic UI page and see examples, tutorial, use cases, everything. And that's a good thing. However, again, the more you write code, the more components you create, the less sense it just all makes. And first thing is, if you have Shiny specific functions, and very importantly, page wrappers like page semantic, which is arguably one of the most important functions in the package, it loads Semantic UI into the browser and makes all other components work. It doesn't fit into the structure. So you create an exception. You create a special folder for functions like that. Maybe you have other functions like helper functions, some calculation functions, validation functions. You also create folders for them. Another problem is semantic. Well, what does semantic even mean in the Semantic UI? The idea is that it uses CSS classes, semantic CSS classes, human readable. You can see the example on the slide. So if I wanted to have a large orange button which has a label but doesn't have a filling color, this is how I would define it. I would call a button component with a class large UI basic orange labeled button. And this is great. This is very flexible. But when you need to package it into a function, it becomes kind of difficult to constrain this flexibility. So you might want to start creating different functions for that. This is, again, a situation where your structure starts to be different from the original library structure. And initially, I had in mind this very clear structure identical to Semantic UI, but ended up with kind of a Frankenstein structure, which has never represented shiny semantic on one hand, but already doesn't represent Semantic UI on the other hand. But I love this Frankenstein, and it works for me. It does its job quite nicely, good enough. But at this point, it's clear that we cannot follow Semantic UI in the footsteps. So we acknowledge that we're now going different. We still take away the project structure and naming conventions for the components, and we start thinking about something different. And the next stage is called PyShiny. So remember how I mentioned the target audience of this package? Well, at this point, it seems that it actually doesn't matter, because no matter the background, the developer will first have to familiarize with PyShiny and then use PyShiny semantic, if at all. And it means that to provide the lowest friction possible in using PyShiny semantic, we really want to align our API with the framework library that we are working in, right? At this point, you might ask, why didn't we just start with PyShiny as the first source of inspiration? Well, this is a good question, a valid question, but we actually specifically decided not to do this, not to mimic PyShiny at the beginning, because PyShiny is alpha. It's very risky to rely on an unstable package, I thought. But in the end, we ended up still trying to follow the PyShiny because it's the approach that makes most sense. And truth be told, PyShiny has been a source of inspiration throughout the whole project, because you just need to know, you need to learn the source code of the PyShiny components are supposed to work, how namespace is handled, etc. And it's handled differently in PyShiny, by the way. But then the problem is that the bootstrap that is used by Shiny and the semantic that is used by Shiny semantic, they are fundamentally different. And some things are achieved in very different ways. And it's really difficult to make the API 100% interchangeable and look-alike. What's more is components naming conventions are different, and we have just taken the Semantic UI naming conventions. Now we are thinking about transitioning to PyShiny. On the screenshot, you can see that this component in Semantic UI it's called dropdown. In Shiny semantic, it's called input. Moreover, dropdown doesn't have a label because it doesn't care about the label. Label is supposed to be a sibling HTML. So what do we do next? how should we do this transition? And it's clear that we need to do this transition. Actually, the experimentation, the project has stopped here, but we still had some time to think about it. It seems like the optimal way would be to have these internal functions that represent the semantic UI logic and structure, like this dropdown, and have external functions that look familiar to the user and which have same function signatures, preferably, if possible, as PyShiny, so that we can achieve that low friction transition and usage and adoption of the library. But this is an open topic, and this is an open source project, so you're welcome to express your opinions and participate in the development, do the contribution. Okay, I think I'm over the clock a little bit, so it's time to sum up. During the experiment, we learned a lot of things. Just translate an R package into Python, or at least you shouldn't. But you can reuse Shiny bindings, CSS styling, and general ideas, which is already a huge jumpstart, right? Considering from building solutions from scratch. Then PyShiny has very descriptive function names, and most of them are very similar to the R ones, both in terms of names and functionality. So it shouldn't be difficult to transition, really. And although it's an alpha, I believe that for a UI component library, it provides almost everything we need, because to build UI components, all you need is HTML tools and Shiny bindings, right? And we have them. And finally, Python is just a great language for software engineering. It has great tooling, great support, great everything. And specifically, it's great for package development because it's a package on PyPI. And although the package is in alpha, it's already accessible. It can be checked out, can be installed, we can gather feedback already if we want it. And we want it. Okay, a small postscriptum. So this talk was about my experience of building a package for PyShiny. But if you're interested more in building applications for PyShiny, there's a blog post on Epsilon website. Feel free to check it out. The link is on the image. Thank you. Let's discuss.
Thanks for sharing your experience with porting an R package to Python. I hope this experience will help future people to port some popular R packages to Python community. We have a couple of questions for you. I like the analogy that building Shiny apps using Rhino does not seem much different from building Shiny for Python. Can you mention some key differences that you saw?
Sorry, could you repeat the question, please?
Okay. So you mentioned that building a Shiny app using Rhino is not as different as building Shiny app for Python.
Right.
So
right.
Can you list any differences that you felt between both?
Well, the differences are, on the first glance, fundamental. It's a different language, right? And when I mentioned that Rhino facilitates the process, it's actually about Python not being so different anymore because you're used to use modules and explicit imports. However, what's different? Quite a lot of things. And I specifically mentioned this disclaimer in a postscriptum. Experience of building a package for PyShiny is very different from experience of building an application for PyShiny because they require completely different things. From the experience that I had of building an application, PyShiny seems great. However, it really lacks the ecosystem that RShiny has. So a Shiny app is not only about building HTML components and structure, right? It's not a landing, it's really a data-driven application that requires some widgets to visualize the data, maps, charts, etc. And it's not that great as our Shiny yet, and we hope to see it change.
Okay. So maybe I'll break this down into two parts. So velocity is a key advantage of Shiny. Is it true that Shiny for Python has this? And the second question is, how is the development experience and development speed for prototyping packages for Shiny and Shiny for Python and packages for RShiny?
Okay. Great question, actually. PyShiny is fundamentally not that different from rShiny. So if you're already familiar with how PyShiny works, which function it has, it should be pretty much the same, right? However, again, it all comes down to ecosystem all the time. In rShiny, you have a ton of packages, and you don't need to implement something because you already know that I can just call this function from this package, and I have this. Here, you might not find that sometimes. Uh, Another part about packages, I think it's comparable. It's not difficult to build a simple R package, and it's also not difficult to build a simple Python package. What's more, there's a ton of tutorials on the internet for Python, how to build a package, how to test a package, how to publish a package, how to publish a package to test mirror of PyPI to see it working, etc. And that all really helps.
Awesome. So maybe we'll confirm this with Winston later today. But what is your preference? Do we call it Shiny for Python or PyShiny?
My personal preference is PyShiny. I don't know. I use them interchangeably.
Okay. Thank you, Pavel, for the great talk and sharing your experiences.
Thank
Uh,
you.